Hello, my Calculus AB students. I'm missing you and I hope you're all doing well. I wanted to give you some extra practice problems or go through some of the practice problems so that you would have an easier time trying to answer the rest of them. So I kind of picked and chose the ones that I thought were more difficult, and I'm in section 10.2 on use substitution, and here we go. So if I look at number one, believe it or not, doesn't look all that complicated, but that 5 creates a bit of an issue. So we're going to look at how you deal with when there's an extra number in there you don't want there. You're always going to pick a u value. You've seen that from the intro video that I did and also from the Flip Math video that you watched. But in this case, you usually take what's inside the root or inside a set of parentheses and you let that be your u. So u is going to be 1 minus x squared. And then you want to take the derivative of that. So if I take du is going to equal 0 and a negative 2x dx. And then I look at what I have up here. I have an x and I have a dx. That's cool. I've got an x and a dx. I don't want that negative 2 there. That's in the way. So I'm going to divide that on the other side and make it a negative 1/2 du is what x dx equals. And that's going to help me when I go to do the substitution. Now, go back to the original integral, this 5 issue. Constants can come out front, so I'm going to make that 5 come out in front. That gives me an x, and then it gives me, I guess I could write this, let me write it this way, 1 minus x squared. It's a cube root, so it's a 1/3 power dx. And the reason I'm doing that instead of writing it as the root is because we know we're going to end up having to find the integral of that, and we're going to have to add a power on and divide by the power and such. So it's easier to see it as a power of 1/3 rather than a root of a cube root type thing. All right, let's do the substitution. I have a 5 on the outside. I have an integral. The x and the dx, they are going to be equal to a negative 1/2 du, and I have a u to the 1/3 power. So what I have is u to the 1/3, that's this part, and I have an x dx that equals a negative 1/2 du. So I'm substituting them back. Pull out any constants. So now the negative 1/2 comes out and joins up with the 5. They become a negative 5/2. The integral of u to the 1/3 du, because I've moved that 1/2 out. Alright, so now I want to integrate that. So I raise it to an additional power. 1/3 plus 3/3, one more power, is 4/3. And I need to take that and I need to, got the negative 5/2 in front, I need to divide it by 4/3. Well, when you divide by 4/3, we've seen this with other problems, that gives us a 3/4 u to the 4/3. And then it's a plus c. And so what I'm going to do is I'm going to multiply that together and I'm going to simplify it. Negative 5 times 3 is negative 15. 2 times 4 is 8. And then I'm going to replace the u with what u is. Bad English. 1 minus x squared raised to the 4/3 power, and then it's a plus c. And so that is my final answer for number 1. There's a lot of fraction stuff going on in that. All right, next one that I came to that I wanted to talk to you about was number 4, because number 4 is not the chain rule. And so if I look at this, there's no chain rule to undo. So it's just going to integrate. You just need to integrate. Just integrate. All right, so if I do that, I end up with the integral of x squared is a 1/3 x cubed. This is x to the negative 2 power. So if I take it and add a power on, I'm x to the negative 1 power. So it's technically going to be x to the negative 1 power, 1 over x, but times a negative 1. Right? Divided by a negative 1, divided by times. And I got a plus c. So I have 1/3 x cubed minus 1 over x plus c. And that's your answer to number 4. All right, number 6 was the next one I chose because it's kind of hard to figure out what your u would be. But the u is going to be the power on the e. This power here is going to be your u. u equals x squared. That means that du equals 2x dx. If I divide, if I look back here, I have an x dx, I don't have the 2, so I'm going to divide that over on this side, make it 1/2 du is what x dx equals. Alright, do the substitution. Here's my integral. The x and the dx are equal to 1/2 du, and I've got e to the u times 1/2 du when I do the substitution. 1/2 comes in front. And so if I integrate an e to the u, I get e to the u. So I have a 1/2 e to the u plus c, and I know what u is. U is x squared, and so I get a 1/2 x e to the x squared plus c, and that's my answer for number 6. So the hardest part about that guy was figuring out that the u is actually what your power is on the e. And then the next one that I want to do is number 7 on this page. And number 7, I'm going to pick, of all these pieces, the piece that's ugliest is this guy that's being squared. So I'm going to let that be my u. U equals the cosine of x. That means that du equals a negative sine of x dx. And so I can see I have a sine of x, I have a dx, I don't have the negative, so I'm going to divide that out. So negative du equals a sine of x dx. And now I'm ready to do my integral substitution. The sine of x dx is a negative du, but this is going to be a 1 over 1 plus u squared, and I have it times a negative du when I substitute that. So 1 minus u squared du with a negative. So if I were to make that prettier, the negative comes out in front, right? And I've got my 1 over 1 plus u squared du. And you say, wait a minute, that looks kind of familiar to me. I hope you're saying that anyway. That looks kind of familiar to me. That is an inverse tangent. Remember that? 1 over 1 plus x squared, I think they had it as the one that we looked at, is really the tangent to the negative 1 power. It's going to be your inverse tangent. So this integral is equal to a negative, this negative, tangent to the negative 1 of u. Well, what is u? U is, so negative tangent, and my u is cosine of x, tangent to negative 1, cosine of x, and then I need my plus c because it's an indefinite integral. So that's number 7. A couple more. Number 11 was the next one that came about that was kind of interesting to me because, again, you don't need to do the chain rule on this. There's an easier way, and if there's an easier way, you want to do that and choose it. So I'm trying to help you think outside the box. Sometimes you can make these easier by manipulating them, and that's what number 11 is all about. It's going to be all about your trig identities. So if you think about your trig identities, tangent, back in the day, you know tangent is the sine over the cosine times the cosine of x. Remember these from back in pre-calc where you were doing identities and verifying and simplifying and such? That's kind of where we're at with this one. If I can remember that, that makes this question a million times easier. So I can see my cosines are going to cancel, and really this is just the integral of the sine of x. And that's mighty simple because the integral of the sine of x is a negative cosine of x. Toss your plus c on there and you're done. So look at that. Because you remembered your trig identities, that one makes it 100 times simpler. Alright, the next one I chose was 13. 13, I usually take what is inside of your parentheses, and that would make this derivative be 2x. Now I look to see to do a substitution, and that's not going to work because I've got a cube root of x. So using u substitution on this in the traditional way is not going to be to my benefit. So again, if I had this, it would be, my u would be x squared plus 1. If I take the derivative of that, that would be 2x dx. And if I were to try to substitute it in, it's just not going to work. So there's got to be a different way. And so let me think about this a little bit. Cube root of x is like x to the 1/3 power. This is x squared plus 1. What would happen if I just distributed that x to the 1/3? So that would be x to the 1/3 times x squared. And if you remember the rules for exponents, you add the exponents when you're multiplying. So if you add 1/3 plus 2, you have 2 and 1/3. 2 and 1/3. If I think of that as an improper fraction, that's going to be 7/3, 2 and 1/3. All right, 7/3. And then if I multiply x to the 1/3 times 1, I get x to the 1/3. And this is what I'm taking the integral of. So I can take just the integral of each piece, add a power on, divide by the power. And that's my plan. So x to the 7/3, if I add a power on, that's 3/3 more, that's 10/3. That's going to give me x to the 10/3 divided by 10/3 makes it 3/10. Remember, dividing makes you multiply by the reciprocal. If I do add a power on, 1/3 plus 3/3 is 4/3. It's going to be x to the 4/3 divided by that power, so it's 3/4. And then put your plus c on and you're good to go. So that is your number 13. And then the last one that I want to do that looked kind of funky to me was number 18. And number 18, you're going to look at this and you're going to let the e to the x be your u. So I should say u equals e to the x. So if I were to find the derivative of that, that's du equals derivative. I love e to the x because it's the same. And look, I have an e to the x dx. That equals du. So that means my integral is really 1/4 minus u e to the x times du. Now that one, you might not have seen integrals like this for a while, but you really do know what this is. This is, if I were to take this, this would be to the -1 power. When I add a power on, I get a power of 0, so then you need to think, oh, that doesn't work. So I've got to think of something else, and I hope the ln's come to your mind, because that's what this is. This one is going to be the ln of 4 minus u, but then times or divided by the derivative of negative u, so divided by a -1. And then a plus c for that guy. So when I put this all together, I get a negative ln of 4 minus u plus c. The only thing is, ln's can only be positive. It's got to be the absolute value of that. And so really that's the only thing you have to add in there, is that it's got to be a positive value. You can't take the ln of a negative number. And so that gives you a negative ln of 4 minus u, absolute value of that, plus c. And that, my friends, is my help for you for these practice problems. If you heard all the beeping going on in the background, it was really cute this afternoon. All the Woodbury Heights Elementary teachers came through town and they were beeping and waving at everybody and thinking of everybody and sending positive messages. So I'm sending positive messages to you. Hope you're all doing well, and I will talk to you soon. Bye.